Now let's do exercise. A sample question from textbook. So this is about a reservation center or call center. How long it takes to answer a phone call. So this is a table. The table shows the data we collected on 5 different days, Monday to Friday. So on each day we take a sample. We record the time for 4 different people. Question. So what is sample size and how many samples in this table? As I said, on each day we take 1 sample. So this is one sample. This is another sample, another sample. So altogether we have 5 samples. On each sample, how many data points we collected? 4 data points from 4 different people. So that's why in this question, sample size is 4. 4 data points from each sample. I collected 5 samples on 5 different days. Sample size 4 and 5 samples. So you have to be really clear about this. Otherwise, when we check the table, you might make mistakes. Now let's work on that. We have to construct 2 control charts, X bar chart and R chart. Follow 4 different steps. So step 1 is to calculate the mean, X bar, and the range R for each sample. So I would recommend you want to pause here and try on your own first, and then you can watch the video. Okay, for each step you can do this. So calculate the mean, X bar, and the range R for each sample. So look at first sample. So what is X bar? So X bar, we basically take average of these 4 numbers. So we have 5 plus 6 plus 14 plus 8 divided by 4. So the mean is 8.25. The range, we calculate the difference between the maximum and the minimum. So maximum is 14, the minimum is 5. So 14 minus 5 equal to 9. Then we can do this for the rest of samples. For sample 2, we take average of these 4 numbers, 8.75. And the range is the maximum 13 minus the minimum 5, so we have 8. So you do this for sample 3, 4, and 5. So this is step 1, calculate mean and range for each sample. Step 2, calculate the mean of X bar and R for all samples. In other words, we want to calculate X double bar and R bar. So what is X double bar? X double bar means the average of the average. So that means I already have 5 average here. So this is 1, 2, 3, 4, 5. I want to take average of these 5 numbers. So the average of the average. R bar is the average of all the range. I have 5 different range here where I take the average of these 5 numbers. So we can do the work. So X double bar equal to the average of these 5 numbers. We have 10.05. R bar is the average of these 5 numbers. We have 5.8. So this is step 2. Step 3, we want to construct the R chart. So construct the R chart, we need to know the value. We have a formula, first of all. We need to determine the upper control limit and lower control limit by using a formula. To use a formula, we need to know the value for D3 and D4. So how do we get D3 and D4? D3, D4 are from a table based on sample size. So when you check a table, you look for the right sample size. For this particular example, again, the sample size is 4. So the upper control limit is D4 times R bar. D4 is 2.282. This number is from the table. And lower control limit is D3 times R bar. D3 is 0, again from the table. So we have 0 and 13.2. So this is lower control limit and upper control limit for the R chart. So we use these 2 control limits to monitor the range of each sample. If the range of sample falls above 13.2 or below 0, that means something could be wrong with the process. So now we are done with the R chart. Step 4, we want to do the X bar chart. So X bar chart is very similar, but we use different formula. So we need a 1 number to construct X bar chart, which is A2. So A2, you can find out the value for A2 from the same table as well, based on sample size 4 here for this particular example. So upper control limit, lower control limit, we use x double bar plus minus A2 times R bar. For A2, we can find the value for A2, which is 7.729 from the table. We do the math, we have 5.82 and 14.28. So from now on, we can monitor, we can keep collecting samples. For each sample we collect, we can calculate X bar. In other words, we can calculate the mean of the sample and compare the mean with these two bounds, two limits. If the mean is above 14.28 or below 5.82, that means the process might be out of control. That means you might need to do some work to identify the reason.